We're going to talk about when to use binomPDF versus binomCDF. This is what a student sent me. I'll give you a second to pause and read. And this in the bottom right corner is what I sent back. The question was a TI-84 question, so we're going to kind of focus on TI-84 kinds of things today, in addition to a little bit of the theory of why this works. But the question was, I got part A with binomPDF, and I didn't know how to do part B and C with binomCDF, but I got the answer anyway with a binomPDF workaround. So how do you do it with a CDF? And so you absolutely can do this with binomPDF all the time, and we're going to talk about that at the end. But here's the answer to the question that was asked of me. Here's how to do this with the binomCDF. We're going to be looking for some sort of signal in the problem that tells us what equation or inequality to write to tell us if we're going to use a binomPDF or a binomCDF. Now, if it's an equals, then that means that I'm dealing with a binomPDF, the probability of exactly this thing happening. However, if I'm looking at a binomCDF, then that's going to be some sort of inequality situation, either a less than or equal to, greater than or equal to situation. So we're going to talk about the difference in when it's less than and when it's greater than. binomCDF adds up everything from the left up to and including whatever you're suggesting. So binomCDF and you choose a 3, that means it's going to add up 0, 1, 2, and 3, or the probabilities of 0, 1, 2, and 3 happening, and then when you add those up together, the C cumulative will be what happens when you add that up, so you get a binomCDF. So whenever it is left side, then that would be a fewer than or an at most, and that's going to be an x is less than or an x is less than or equal to, and that's a binomCDF because it's the left side. However, when you have a more than or an at least, that's an x is greater than or an x is greater than or equal to, and we actually want the right side. So what we do is we take 100% of everything under the bell curve and subtract off the part that's on the left, which is why we have 1 minus the binomCDF. So the binomCDF is going to be the left side, and so what we do is we say everything minus the left side that we don't need, and then we have the right side that they ask for. So a few caveats. As long as your count stays reasonably small and we have a number of trials like 10, 15, 21, it's not going to be too bad. And we can always use a PDF in the list menu, and I will show you how to do that at the end. Some people don't want to bother with the whole CDF situation, but I was asked to talk about what the CDF does, and so I'm going to do a compare and contrast. But there are some problems that are, for 850 participants who bought plane tickets, what's the likelihood that 724 of them will, and at that point you're dealing with hundreds of entry values, and so we don't want to deal with a PDF at that point because that's just too many things to put in the list menu. But that's kind of a rare occasion for this course. It's kind of a fun thing to know, but mostly you'll be able to use a binomPDF for everything if you really want to. Another thing is I ask AI to make up some fake problems with nonsense words because that very much amuses me, and it's not really the content, it's really the technology and some vocabulary words that we're talking about today. Another thing, that there's a grammar situation. I'm going to be talking about fewer than, and fewer than would be grammatically correct because we're talking about discrete things. So you know how discrete things are countable things, and that's when we're going to say fewer than, like how many people are in this room. Fewer than 10, I can't say less than 10 because I can't have a partial person. So anytime things are discrete, we're going to say fewer. However, the actual symbol we're going to use mathematically is still going to be a less than symbol. So, grammatically speaking, fewer, but, the symbol has a name. So we're going to be talking about that a little bit. This is what happens when people who talk about math are spawned by English teachers. And the very last thing is that this is going to be heavily TI-84 oriented because that was the question that was asked of me. And by all means, please pause as necessary because sometimes, surprisingly, I am not long-winded enough and you need more time to read all the things that are on the screen. So I expect you to be pausing often. Another thing is don't trust the AI. I ask it to create these problems, but I had to correct it 5 times. But it's my job to correct it, so, got this. Because it says exactly, I'm going to go to second, vars, my distribution menu. I like to go up, but it's because exactly, it's PDF. Exactly is a PDF situation. So the number of trials, we have 10 trials. P-value has to be written as a decimal, so 0.3. You can say 0.30. I usually say 0.3 because I'm lazy. And then 4 is the number that we want to find exactly. So paste on the screen, and there you have it, my friends. So now we're looking at Snorplaxing speed. That entertains me. So now the important word here is that it says at most. And at most is going to be very relevant to us because that's an inequality kind of word, which tells us we're going to be using a binomCDF this time. So second vars, and then I go up here, and I'm going to go all the way up to binomCDF. And then the number of trials is 8. P is 0.6. And what I'm trying to test out is up through 5. Ta-da! So the nonsense word here is blibrium. That's fun. So there are 12 trials, and we want to know what's the probability of getting 11 or 12 of them. So it says at least 11. So out of 12 trials, then it would have to be 11 or 12. So what we're going to do, because binomCDF is on the left side, we're going to take 1 or 100% of everything, and we're going to subtract off all the left side stuff that I don't need. So the things that I want to keep are 11 and 12. The things I don't want to keep are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here's how we're going to do that. I'm going to do 1 minus, and then I want to go up to my distribution. binomCDF. We have 12 trials, 90%, and I want to take off everything up to and including the 10, and that way it'll leave me with 11 and 12. So it'll say 1 minus binomCDF whenever I have a pointing right side of an inequality symbol. So x is greater than or equal to 11 would look like a 1 minus a CDF. So each person exposed to Zindel has a 15% chance of starting to dance. Well, that's fun. Now, the reason I have this screen on there is that there are 5 different possibilities, and I want you to see what they would look like, each of the 5 possibilities, and compare and contrast them. So what's the probability that exactly 3 people start dancing? Because it's exactly, it's a binomPDF, and we use a 3. But then it says, what's the probability that fewer than 3 people start dancing? Now that's binomCDF, but because the binomCDF is inclusive, that's why I have the binomCDF up to, including the 2. That way, if I will find out how many people are dancing if it's 0, 1, or 2, or what's the probability of 0, 1, or 2 people dancing, but not 3. The next thing is, what's the probability of at most 3 people? Well, that's almost the same question, except that this time I get to include the 3, so that's 0, 1, 2, or 3 people dancing. And so that would be binomCDF, but using a 3 this time. The next one says, what's the probability that more than 3 people start dancing? So the probability that more than 3 people start dancing means that I'm going to not include the 3. So the way we're going to do that is we want to say 1 minus, and then binomial CDF of 0, 1, 2, and 3. Now I said I'm not going to include the 3, and that's because I'm subtracting off everything up to 3. So 0, 1, 2, or 3 people dancing we're going to take off, and that's why it's binomCDF with a 3 in it. The very last one says, what's the probability of at least 3 people starting to dance? So that means that it's not 0, not 1, or not 2, so it's 1 take away the binomCDF that includes 0, 1, or 2. That's why there's a 2 right there. Here's all of that information as a pretty little chart. Here are the answers to everything we've done so far, rounded to 3 decimal places. Now, if you want to use PDF every single time and you don't want to use CDF at all, that's certainly fine as long as you have a reasonably small set. So here's an example that has 15 trials, and then what we're going to do is we're going to go to our list menu, Stat Edit, and this says that 6 or fewer times. So that means that I have to count up to 6, starting with 0. So 0, 1, 2, 3, 4, 5, 6. So this makes sense, 6 or fewer times. Don't forget the 0. The 0 is very important. I'm going to go over to L2. I'm going to go to the name of L2, and I will tell it to evaluate binomPDF. There are 15 trials. The p-value is 0.4. The x value is whatever L1 says, because I want it to do this over and over and over again. So instead of giving it a particular x value, we want it to do this 7 times, 0 through 6 times. Here's what it looks like here. You hit enter one more time, and it gives you all of these probabilities in L2. So we're going to go second quit. You can do this one of two ways. You could either look at one var stats that's in your stat menu, or you could go, what I'm going to do is I'm going to go to second list. I'm going to go over to math because I wanted to calculate. Number 5, the stuff I just put in L2. There you go. And this is just showing that if we take the sum of all of the relevant binomPDFs, that would give us the same answer as the binomCDF of 0 through 6. Here are a couple more for you to try on your own. Your job is to, first of all, identify if it's binomPDF or binomCDF and how you want to accomplish that. Answers to come. Here are the answers to everything rounded to 3 decimal places. The Warbly was a binomPDF, and the Quibble was a 1 minus binomCDF. How'd you do?